Nick Clouser, Hunter Fox, and Taye Sayre were sponsored by SKF to do a material selection and characterization for food packaging slewing bearing.
SKF's current solution is a stainless steel bearing. Is very expensive to produce and very over-engineered. Right now, they last anywhere between 5 to 10 years. They produce less than 1,000 per year, and their minimum goal is to reduce the cost by 20% while still meeting application requirements.
So for our material and process selection, we looked at 6 different engineering semi-crystal materials. We narrowed that down to POM and ultra-high molecular weight polyethylene due to processing. Um, and then for our experimental results, we did an accelerated aging test. Uh, this simulated it in the application up to 1.5 years at 23 degrees Celsius. And both materials were determined to have no significant change in stress or strain at yield loss after being simulated for this time.
For the DMA results, the RPMs that drive the motor didn't have a significant effect on the mechanical properties, as the temperature was the biggest factor.
FEA analysis was also conducted, and it was seen that both materials saw statistically similar stress levels on several phases of the sample. The levels of stress seen were significantly below both yield points. Ultra high molecular polyethylene saw more deflection in the analysis than the POM, but not enough to cause a concern. Typical applications would see contact on phase number 4, where POM saw 15 safety factor and ultra high molecular weight had a safety factor of 5.
Then we did a cost analysis with 2 different processes. One, they purchased the sheets from a supplier, machined 2.3 gears per sheet, and then CNC'd those out. And then the other process, they purchased a machine and mold, compression molded the 1/3 pieces themselves, and then CNC machined it. POM was able to have a cost reduction of around 17%, and Ultra High was able to have a cost reduction of 20.25% when purchasing the sheets from a supplier. FEA proved the material could withstand the loading conditions. POM had a safety factor of 15 and Ultra High had a safety factor of 5. DMA proved that the frequency of 0.33 hertz did not have a significant impact on the storage modulus over time. Accelerated aging proved that POM and Ultra High were not impacted by the environment of the application. And from the testing that was conducted, both materials were determined to be a successful substitute in application.